Good evening and welcome everybody, this is Obi-Wan Pez for Simplex Pachinko, and we are going to be doing some math stuff tonight. So, as we have been doing for the last few... As we've been doing for the last few Mondays... It's me. We are going to be working with... I didn't put in a category. That's a silly thing to do. Obviously, we want to be in the math category. Yeah, we're going to be looking at Peter Liljedahl's Building Thinking Classrooms, which has been an interesting exercise in questioning the institutional norms that we have through our teaching experiences, and then attempting to see what we can do that's greater than what we have been doing, whether that be for the last few years or for the last few decades or for the last century and a half, ever since institutionalized education kind of became a thing. Okay. So in chapter 5, so the fifth major point that Peter Liljedahl wants to bring up is that we need to question how it is that we answer questions inside of a thinking classroom. So he does go through and state, just real quick, like, we also have this common notion, and it's well studied, that teachers are question askers. And here's a link for the book. If anybody is interested in getting the book, it is at Corwin, and you just need to search Building Thinking Classrooms if it is something you're interested in. Again, this is mostly for math teachers. So I don't think pretty much anybody's going to be all that interested unless you are like doing educational policy or specifically mathematics teaching. Anybody else, it might be a good paperweight. It might be a good read if you're just interested in the subject, or it might be a good addition to your local library. But maybe try to ask them first or see if they can get it for themselves. don't necessarily show up with a copy and say, hey, thought you might like one. They don't like that. Definitely don't know that from experience. It wasn't this book, but it was like a bunch of books that we were trying to get rid of. They were like, yeah, we don't just accept random donations. I'm like, you're a lot, really? Apparently not. Okay, so so Peter says, and this is going to be mostly a series of quotes and paraphrases, just so that everybody knows ahead of time. I will bring in my takes anytime that I have specific experience with a particular section. But again, for the most part, most of what we're doing here is quoting and paraphrasing Peter Liljedahl in both the book, his keynote speech that he gave at Amatic 2022, I think it was. Yeah. Amatic 2022, and anything else that I've found, like, online. We'll try and quote as much as we can. And again, personal experience kind of comes last in all this. So, quote, much has been written about the effective use of questions from teachers to direct students' thinking. And this is naturally something that has been done throughout my professional development. So anytime that I'm doing a professional development series, it almost always ends up being something to the effect of, here are better questions that you can ask your students, or here's a better way to ask your questions, or all sorts of stuff like that. I will draw on some of that literature when I discuss the use of hints and extensions in Chapter 9. This chapter is more concerned with how teachers answer students' questions, and the effect that this has on getting students to think or not. By the end of this chapter, you will have learned what types of questions students ask and which ones we, as teachers, should be answering. So the first real step that we need to look at is we need to differentiate between types of questions that students will ask. Peter says that we've got essentially two different types. There are the stop thinking questions and the keep thinking questions. You may be familiar with research showing that teachers ask up to 400 questions a day. This was from 2008. But a more interesting question as it relates to thinking classrooms is how many questions teachers are answering. And one of the things that becomes immediately apparent, one of the things that became immediately apparent when I was first observing classrooms is how much time teachers spend answering students' questions. At first, I saw these answers as background noise to the central focus of the teacher's plan and delivery of the lesson. But as I began to pay closer attention to how teachers answer questions, I realized that this background noise can become overwhelming over time. After an initial study to gauge how answering questions is related to student thinking, I came to the startling conclusion that a typical teacher will answer between 200 and 400 student questions a day, with some answering as many as 600. And I don't think that that means they're answering their own questions as they're asking them either. The problem with this is that answering all these questions is antithetical to the goal of getting students to think. In fact, my research on the other 13 practices show that practices that could get students to think were often being undone by teachers answering every question being asked of them. For example, giving students a thinking task is pointless if we then proceed to answer all of the questions that they ask, and especially about how to solve a particular question. If you're just constantly answering, how do you do quadratic formulas? How do you do this next step? How do you do this next step? Obviously, the student is never going to get anywhere on their own. Likewise, randomizing students into groups of 3 does not foster collaborative sense-making when we, as teachers, give away the sense made through our own answers. Yet, answering questions is as much a part of being a teacher as asking questions is as a part of being a student, and it's a habit that teachers will find difficult to change. So what do we do? The questions are not going to stop coming, so what do we do instead of answering them? The answer lies not in whether we answer students' questions, but which questions we answer. So as it turns out, students only ask 3 types of questions. Stop thinking, keep thinking, and proximity. Proximity questions are those that are only asked when the teacher is nearby. If you weren't there, that question never would have been asked. In some cases, this amounts to students being attempting to become better studenting, or attempting to show off their better studenting behaviors. So, for instance, students will ask questions in order to gain social points with the teacher. That's one reason students will ask questions, and oftentimes those types of questions are a subset of proximity. So one of the ways that we can prevent that from happening is get them to understand through action, inaction, answering, not answering. Get them to know that, you know, we don't need to have this standard classroom relationship in this room where sorry, this is distracting me. Give me a second. No, that's not what I wanted. Oh no. Anyway, make sure that you are not reinforcing the idea that students are good students when they're asking questions. It seems kind of absurd because of course they're going to ask questions, and of course you should reinforce it, sure, but not in a way that they're going to think that the only thing that they need to do is just show off, that they can ask questions and be a good student for that minute and then like slack off the rest of the class, right? What we want to encourage is that they are not asking us questions in order to show us that they are good students, but rather we want them to ask questions in order to collaborate better with their peers. So if they're asking us questions, have they really worked that out with their peers? Are they gaining that cooperative spirit, or are they just trying to get the answer? Or are they just trying to look good in front of the teacher? There's a few different ways that can go. On the surface, these questions are no different than questions asked in the other two categories. What is different is that the student does not put up their hand or walk across the room to ask it. From the studenting research discussed in the introduction section, we learned that in many cases students ask these proximity questions more for the sake of conforming to the role of student than for the sake of getting an answer. So, like I was saying. In many instances where I saw proximity questions being asked, immediate follow-up revealed that the information gained from the answer was not being used at all. In fact, most cases, proximity questions consisted of queries about things that students had either already figured out or made decisions or assumptions about. They simply asked the question because it was habitual, and it was the studently thing to do when the teacher happened to be standing nearby. From role theory, Horowitz, 1967, we know that the drive to conform socially defined roles can be very strong, even if totally subconscious. In a classroom, the dominant roles are that of student and teacher. Asking a question, one of the most studently things that a student can do, cements their role in the eyes of the teacher as student. Conversely, answering a question is one of the most teacherly things that a teacher can do, thereby solidifying their role. So this also goes into a bit of it's like Horowitz in role theory also links so role theory again. The student and the teacher will often try to cement their roles through their behaviors, even if that interaction is unnecessary or even contrary. To their intentions, I guess. This has also popped up a few times in Bell Hook's Teaching to Transgress, wherein people are more interested in keeping their social roles and ensuring that social order is maintained rather than making any sort of progress in education. Bell Hooks does not teach mathematics, but nonetheless, it applies across the board in all of teaching. In addition, her original source that she has been looking at was Paulo Freire. And Paulo Freire, apart from being a raging misogynist, also had some decent educational views that involved ensuring that revolution in the classroom was in fact a good idea, that we should be encouraging our students to seek new ways of being students, seek new ways of reaching new heights. Now, granted, maybe this was also in more like college level, so there wouldn't be as many like behavioral problems and things as there are in younger schools, but nonetheless. Just as a reminder, Bell Hooks grew up in a segregated school, and like those teachers had taught her and all of her peers in the black school that or how to exist in society as a black person. And it is very eye-opening to see that sort of that side of history, I guess, because, of course you don't learn about this sort of stuff. You learn that there were segregated schools, and then they integrated them, and all was hunky-dory, and it was all sunshine and rainbows from that moment on, right? Right? No, of course not. But here's the thing, right? When the schools were integrated, the black teachers and the black students were moved in with the white teachers and white students, and then, as it turned out, integration was acquiesced to, not just because of some highfalutin, left-wing ideology that told everybody that you all need to get along and be happier and things like that, and, it's wrong to segregate society. It wasn't just that allowed some of those southern states to get together and say, okay, fine, we're going to segregate, or we're going to integrate. No. In fact, many of the ideas behind integration in the South were that, hey, this will prevent the black teachers from being able to teach their black students how to engage in social justice practices. They would be effectively watered down inside of an integrated school. And in that way, they're now getting pushback from their peers about, like, well, I don't really... Well, from their white peers. About, like, well, I don't really understand what you all are yelling about because we're integrated now. Everything's happy. And a number of other things that were going on, like their black teachers were now no longer able to teach social justice practices, and trying to get them to understand that, yes, society is unfair, but here's what we're going to do about it. They were now no longer able to teach that. I wanted to get that out.
Honey Power Games gives you more chances to win. Imagine that. Life with more chances. Fashion people have a bold idea for men's bringing back its 70s classic. The mullet. Security. Party Power Games. 1 spin per player per day. Each prize carries individual T's and C's. Eligibility rules and T's and C's apply. 18 plus. BeGambleAware.org.
There's more to Spotify than meets the ear. That's because video is taking center stage on Spotify. With over 300,000 video shows and 300 million users already watching their favorite podcast. With seamless switching between...
Really, the important part to remember is that all of this comes down to the construction, maintenance, and perhaps demolition of power structures. And really, where should we be putting our efforts? Where should we be putting our energy? So, Paulo Freire says that effectively revolution within academia is absolutely and wholly necessary. Did I not just finish that word? Bell Hooks takes that idea and starts working in the context of the United States and saying, like, we should do more to break these social norms. Horowitz is talking about role theory, how the student and teacher want to cement their roles in these, cement their place in these roles through their behaviors, even if, like I said, the interaction is either unnecessary or contrary to their intent. Hooks does say, again in multiple places here, that, look, Paulo Freire was a raging misogynist, and it is his views are antithetical to much of what she is saying in terms of, well, we need to break these social norms. Thank you for the follow. But at the same time, Freire's work is extremely useful, and in using his work, some people would delegitimize Hooks's other work or her use of much of this educational theory, and just say, no, you know what? He's a raging misogynist, therefore he has nothing to tell us about power structures in general. And Hooks said, look, this is extremely short-sighted. You need to start using the good stuff and say, yes, he was a raging misogynist, but we can still apply what he said to a greater context, and in so start taking down some of the either social norms or institutional norms, if we're talking about Peter Liljedahl's talking about, that are no longer useful and no longer helping us. If they're no longer helping us or our students, then why are we doing them? And if there's things that are just racism, then yeah, we need to deconstruct all of this and figure out how exactly to break it all down. Okay, so these are two optional author readings that you all should definitely get into if you're at all interested in educational theory, and trying to understand education as social justice and education as that's one of the reasons why so one of the reasons why the extreme right wing really hates education. Right, education as social justice and education as a breaking of power structures. Education is our wrecking ball. I'm not even kidding about that. So Liljedahl comes over here and says, okay, looking at all of this stuff, and I'm sure that he's used Frere and hooks at various points, but none of them are explicitly mentioned, I think, for most of the book. In using Horowitz's role theory, he's saying, okay, pretty much the proximity questions are asked only to cement their role as student, and answering the questions are to clearly cement our roles as teachers. And we've got to get away from this whole thing, right? Get away from role, get away from the necessity of role theory as it sometimes is taught to teachers, or as it is sometimes just kind of like our natural instinct, both as students and teachers. See if this sounds familiar. It's toward the end of a lesson, and you've given your students some seat work to complete before they leave. You notice that one of the girls near the back is paying an awful lot of attention to something in her hands. You suspect she's doing something on her phone, but obviously you're not going to call her out. And you can't quite see what it is, as her textbook is blocking your view, so you walk up the aisle toward her to see what's going on. She sees you approach, makes a few brief movements with her hands, and then as you get closer, you can finally see over her textbook, and you notice that her phone is on the calculator app, lying on her desk. Now that you're there, she can ask you, rather guiltily, so for question 11, are we supposed to find all the answers or just one of the answers? You respond to her that she's supposed to find all the answers, and walk away, satisfied that not only is she on task, she is ahead of most students in the class. From my position in the back of the room, however, I can see that your first instinct was correct. She was, in fact, on her phone and not on the calculator app that you saw, but communicating with her friends through a social media application. As she saw you approach, she quickly switched over to the calculator app, a perfect subterfuge. She has completely managed to cover her tracks, and she knows, as do you, that you would be hard-pressed to prove otherwise. So why the question? She'd gotten away clean in the first place. She asked the question because, and this I have asterisked, bracketed, and underlined multiple parts of it. She asked the question because, whether you knew it or not, she was out of position, acting outside of her role as student. The question, the answer to which she does not need whatsoever, was the quickest way to get back into her socially defined role of student. By answering it, you not only reaffirmed your role as teacher and her teacher, but also acknowledged that she was now in her role again as student. So, all of this comes together, right? This is all about role theory and, more broadly, power structures. So what kinds of power structures are going to exist in your classroom? The power dynamic that naturally exists between student and teacher is something that we just kind of appreciate and say, like, yes, this is how it is supposed to be. This is how students and teachers are supposed to interact, right? We have the power, we are giving a bunch of stuff to students. Evening, Zach. How we doing? Saw you doing some coding tonight. Looked pretty great. Didn't stick around for long, but you know. Had to see what it was. For next Friday. Nice. Alright, so in many cases this is exactly what all the rest of the students are doing, even if you don't know it or you can't tell, or even if you can, even if you catch somebody completely red-handed. They might ask you a question in order to get back into their role as student, so that you can be like, all right, well, at least you know what you're doing, because now you've put your brain back into student mode. This is not to say there were not instances of students asking genuine questions as the teacher was close by. Of course this happens. It happens all the time. But when it did, follow-up with the teacher often revealed that the students who asked proximity questions were either shy or had very good work habits. In the former case, these were students who did not want to draw attention to themselves by raising their hand or getting out of their seats to approach the teacher. Instead, they waited until the teacher was very close by, then quietly asked their questions of the teacher. Teachers seemed to have a sense of this and were drawn to these students in anticipation of their questions, either from prior experience or subtle signals from those students. In the latter case, rather than take the time to put their hand up and wait for the teacher to come to them, or to walk across the room and wait in line with students with questions, these students chose to save their questions for when the teacher was close by. In the meantime, they proceeded with the rest of their work. They continued. They went and they, in our previous chapters, we called this Just Try It, right? They went on to different questions and just tried it. But regardless, the number of students with legitimate proximity questions paled in comparison to the number of proximity questions asked for the purpose of establishing or reestablishing their social roles, their power roles. So, Freire, Hooks, and Horowitz all came up with stuff that has to do with power structures, the natural power structures in the classroom setting, and somewhat how to also break them. Again, especially Freire and Hooks in that respect. Freire being an actual social revolutionary from Brazil, I think, and Hooks being somebody who grew up in segregated America and then moved to an integrated school, where it was, in fact, worse. Because, again, this was the South. It was all about making it worse. No offense, like, to people from the South generally. It's just like, know your history, right? Okay. Second type of question is the stop thinking question. The most common of which, probably in a math class, is usually, do we need to learn this, or when are we going to use this? Is this going to be on the test? More often, however, Peter says that the varying form of the question. Am I right? Was one of the most common stop-thinking questions that he saw, and again, and its varieties, like all of its different forms of am I right, was one of the most commonly asked question in all of his studies over 15 years, over 400 professors, or, it's 400 teachers. Question could be about an answer they have come up with, their progress on a thinking task, or the way in which they're following your instructions. Regardless, these questions are motivated by the reality that, for students, thinking is hard, and it's hard to decide for themselves if what they're doing is correct. If they could just get you to do that for them, their life would be so much easier. So students ask this question with the hope that you will answer it and they can just stop thinking. My note here says, do you feel called out yet? I have, in fact, written that in multiple places in the book. Both a question for myself and for me to ask other people. Right? Thinking is hard. If you can do that for them, their lives would just be so much easier. So, again, try to resist the urge to just answer questions for the sake of answering questions, as with proximity questions. Don't answer questions that prevent students from doing hard work themselves. They need to still be able to think through things. So one of the things that I kept doing throughout my career, the first 15 years there, was to start realizing that I need to ask students more questions rather than dead end something and be like yes or no. In fact, if I just answer no to am I right, that is a rather interesting way to answer it, because now you've got now you've got to actually think about why I said no. But keep thinking questions, right? So these are asked by students so that they can continue to engage in the task at hand. These are often clarification or questions about extensions that the students want to pursue. So students who ask those questions are motivated to keep going, to keep working, and to keep thinking. So, the two types of questions that students are going to be encouraged to ask, as many as they want, as often as they want, and to as many other people as they want, are those of, again, clarification and extension. These are the only ones that we should be answering, really, at least in a fairly simple way. However, you also want to ensure that your answers are of a variety that are going to, again, encourage the students to keep thinking about it. What do you mean by this? Right? That is actually a clarification question that could be brought right back to the student. So if you answer a question with a question, it aggravates the hell out of everybody. However, it is actually most of the time appropriate. All right, so that's one get out clause. So simple ones might be, can we get the next question? When you say that numbers add to 25, do we just have to stick to whole numbers? Ooh, that's an interesting question, right? Two numbers, they add up to 25 and some other information. Do they have to be whole numbers? Well, why don't we stick with whole numbers first, and then we'll put that on a list somewhere and be like, okay, we'll work with whole numbers first, and then like A, part A, whole numbers. Part B, what if it doesn't have to be whole numbers? We want to try to solve this for the negative case as well. Is that fine? Yes. When we get to Chapter 9, we'll see students will eventually stop asking you these types of questions as they start gaining confidence in their thinking and just create extensions for themselves and talk with their peers and say, hey, what if we did this? It's really cool when this happens. It doesn't happen very often for me. So, toward a thinking classroom. Turns out that approximately 90% of the 200 to 400 questions that teachers answer in the day are some combination of stop thinking and proximity questions. How many of these are proximity depends on how much the teacher circulates around the room during the lesson. Teachers who spend a lot of time circulating receive many more proximity questions than those who circulate very little or not at all. Regardless, answering these proximity or stop thinking questions is antithetical to the building of a thinking classroom, naturally. In the best case, the answer would be redundant. In the worst case, it would shut down thinking. The only questions that should be answered in a thinking classroom are the small percentage, approximately 10%, that are keep thinking questions. But this raises two new problems. How do we quickly discern the types of questions being asked, and how do we not answer the other 90% of them? So, again, problem here. Right? How do we effectively go about separating out our keep thinking questions and saying, yes, I would love to answer these questions and point them out and encourage other students to do that. And also discourage, but not in a mean way, right? While getting students more engaged. You ask these questions that really I don't want to answer because, again, either you're just asking for social points or you're trying to get out of thinking yourself, right? I don't want to call a student out on that. That's mean. And they would probably be like, jackass, why would I want to, like, hey, Lucas, that wasn't to you. Right? How do we discourage these types of questions while still engaging those students to higher levels of thinking. So trying to get them to be like, hey, why don't we try a little bit harder? Why don't we try a little bit different wording on your question? It might be more interesting to ask. So the first of these issues turned out not to be a problem at all. The teachers I was working with quickly learned to discern a keep thinking question from other types of questions. So, super easy. Genuine question, yes. Why is 1 over positive infinity not equal to the limit as x goes to 0? So 1 over infinity is technically undefined. So if you just say, I want the number 1 over infinity, there is no number which aligns to that. There is, however, a number that we get closer and closer and closer to as x as x goes to infinity, right? Or I think maybe I'm missing some characters there, but limit as x goes to 0 of I can't think of a good reason why x going to 0 is going to be nice in there or get us infinity. But point taken, right? Why is this not just 0? So 1 over infinity as a number is undefined. Infinity is not a number. It is a conceptual idea, and it is also a limit. So infinity is a limit itself. We're saying, like, as x gets really, really, really big, as x goes to infinity, 1 over x starts getting closer and closer and closer to 0. So that, yes, eventually it will align with the value 0, so close that we can't even measure a difference between the two of them. Yeah, once you're within the Planck length, like, we're just going to wave our hands and say, yeah, that's close enough. But yeah, we can't say that specifically 1 over infinity just is 0, because again, it's undefined. So once we understand the concept of limits, it becomes a little bit easier to say, like, okay, well, there are sort of. So here's the easy way that I do for that one, like 0.99 is equal to, etc., is equal to 1, right? Or 9.99, etc., is equal to 10. The easy way to do that one is if two numbers are distinct from one another, they must have an average. If two numbers are distinct, they must have an average, and thus it creates another number between them. And if that number is distinct from that number, then they have to have an average, and they have to have an average, and they have to have an average, and it continues ad infinitum. So yes, because you cannot have an infinite number of zeros followed by a 1. It would have to be a finite number of zeros, and then in that case, that is different than 0. Right? If it has a finite number of zeros, then it has an average with the number 0, and therefore they are distinct from each other. If it has an infinite number of zeros and then a 1, there's no such number. It's always a fun question. You could also argue against that by saying, "Oh yeah, yep, yep." I was always in. We were in Algebra 1, I think, when we started in on some of those questions, and then like Algebra 2 Trig was like when we started honing in on all of these like meme things. But this was before this was before like serious internet. Before there was any actual like meme out there. Most of us did not know the word meme. It was not even a thing yet. It was in Richard Dawkins' book, The Blind Watchmaker, maybe? Or The Selfish Gene, maybe both. He coined the term meme, being a, like, memory gene. Something that will cycle through people and spread through populations and things like that. So the other way to counter your infinite number of zeros then a 1 is ask, how can you have an infinite number of something and still have a concept of after? Right? There is no after if you have an infinite number. All right. Actually, this is a good place to break. Lucas, if you have any other questions, we get about 2 minutes, but otherwise, I will run downstairs, ensure that everything's going all right. In this case, you could say, what is your concept of size? If it is truly infinite, does your concept of size matter anymore? Like, technically, sure, it's twice infinity, but twice infinity is also infinite. So, the other thing that you can do, and this is a fun one, is yeah, Zach's got it. They have the same cardinality. So what you're looking at is the cardinality of a set of numbers is the size of that set of numbers. And like, how can you come up with a size of an infinite something? Well, one of the ways that was developed by Georg Cantor in Germany, well, what would become Germany, was if you took a set and then you were able to map it 1-to-1 with a string of integers, then those things are of the same size. They don't have to be literally the same size, but they are of the same size. So if we took the infinite set of whole numbers, natural numbers, so all the positive integers, and then counted up 1, 2, 3, 4, 5 with all of these other numbers in a different set, we could show that this has a countable number of numbers in it. So it could be countably infinite. We'll come back to that. Ads are just about to start. So 3 minutes, everybody. See you in a minute. Or see you in 3.
you're listening. Smart Shuffle can weave in song recommendations for your playlists when you join Spotify Premium. Or start a jam, where you can invite your friends to create and add to shared playlists, all with unlimited skips and repeats. Tap the banner to learn more.
There's more to Spotify than meets the ear. That's because video is taking center stage on Spotify, with over 300,000 video shows and 300 million users already watching their favorite podcast. With seamless switching between watching and listening, you can tune in anytime, anywhere. Got a show of your own? Upload your video to Spotify, turn views into fans, and monetize your passion.
Awesome. Perfect timing. I mean, Americans do. Typically, Stephen Hawking, for example, probably would have said finite and infinite. Although he was also Cambridge, so much more refined. Yeah. But yes, we, pretty much everybody here, I think, is in fact American, so, yep. Whew. Oh, okay. Oh, that's right. You're, Nederlanden? Yeah. I do not speak any Dutch whatsoever, unfortunately. We had a bunch of... This is not Netherlands, but nonetheless. We had a bunch of Danish students who came to our college one year as like a, I don't know, it was like a 2-week thing. But they have like a sister college that we've partnered with. And they sent us, 30 some odd students. No. Well, maybe. There were about 10 who were interested in coming to my math class. And I did one of my regular lessons. I started talking a little bit about math history and did some, stuff up on the board and thing like that. And then, with a few extra double A's and stuff like that. Yeah, so I like pull up a few Danish phrases so that I could like impress them with, hey, something, and they were just like, No, I don't know what you're saying. I'm like, oh, no. The nice internet lady said I was, or, you know, the nice internet lady sounded like this, and so I'm repeating it. Guten Tag? I believe the phrases that I chose were basically like, you know, good morning, good afternoon, it's lovely to see you or meet you or something like that. Have any of you studied math? Please excuse me, I speak not a word of Danish. Or, yeah, please excuse me, I speak not a word of Danish. Guten Tag. Oh, yes. That, yep, I just said it out loud, and now I know what it is. Damn it. Ooh, this one's nice. Hey, Famished, how's it going? Tonight is hashtag not sponsored by Breakwell's Seedling Single Variety Organic Cider by Dunkertons in Herefordshire. So, pretty close to Yorkshire. Lovely little thing. Actually, my spouse would have liked this one. It is hashtag not sponsored. I had to, well, actually, I was given this one by our American neighbors who have moved out. So they are headed home, and goodness knows what they're actually going to do once they get home, because I think at first they're going to try to not rock the boat and get summarily dismissed from their positions, and after that, who knows? Right. Right. Hang on. Wait. I was going to, and I showed these during break, but nonetheless, two really good books about like cosmology. So anybody who's interested in trying to figure out origins of the universe, all that good stuff. Stephen Hawking's The Original, A Brief History of Time. Brilliant, amazing, difficult read, but you know, I could say that this is like the absolute seminal work. If you understand everything that's in here, you're going to understand at least the context by which you might be able to figure out some of the other cool cosmology stuff that's going on. Stephen Hawking also, The Universe in a Nutshell. This one is a bit newer. It's also illustrated with a bunch of pictures. It has a lot of the, not same, but it has a lot of similar content to Brief History of Time, but it does it with cool graphics and pictures and stuff like that, and it helps understand the concepts better, even if you may not fully grasp what he's getting at. A couple of other ones. Charles Zaifa, Alpha and Omega, also about cosmology, how the universe began and how it's going to end, as far as we can tell. How the Universe Got Its Spots by Jenna Levin, who is currently one of the hosts of Star Talk Radio with Neil deGrasse Tyson. And, of course, Neil deGrasse Tyson, Astrophysics for People in a Hurry. Quick, easy to read, as long as you mostly understand it. There's some other really cool stuff that's going on in the world of cosmology, but also, like, astrophysics is mostly about doing some of the doing the readings of what's going on out there, which involves both cosmology and also like exoplanet research and also black hole research and also, so there's a whole bunch of areas within astrophysics that are looking for a lot of help. If anybody's thinking about it, it's a good place to study. I'm a bit biased because I was going to definitely go into theoretical astrophysics, specifically black hole research, in my freshman year of college, when I realized that the Great Wall of Thermodynamics was probably not going to go well for me. They had a 39% pass rate at my institution, and I said, So I decided to become a math teacher instead. It only took me 12 years to start, like, really coming into my own in math education. It's just that I'm very enthusiastic about math education, and as much as I would have been enthusiastic about astrophysics, I think it would have taken me probably a lot longer to figure it out. And to like get where I was going to go. The other possibility is that I would have seen all this exoplanet research and been like, nah, screw it, I'm going there. That was a mistake. Yeah, so nuclear, now, like right now, I think I could probably get through thermo pretty easily. But when I was a sophomore in college, or freshman in college, thinking about my sophomore year, I at least had the wherewithal to think to myself, this is not going to go well. Now, oh, Zach, you're gonna be super proud. I went back yesterday, or maybe 2 days ago, and I looked at the tensor calc book. Not that one. Is it in here? No. Well, I'm not going to find it super easily, I don't think, but, oh, right, you just hit the... Jeez. Just literally, just type it in the address bar, and it says what tabs are already open. Amazing. Pavel Grünfeld released this book, Introduction to Tensor Calculus, and I started reading it probably 3 or 4 years ago, because I was like, I think that my the stuff that I need in my research for the simplex and trying to do like sums of all sorts of stuff, I was pretty certain that I was going to need better notation. So I said to myself, I'm gonna probably need to look into something like tensor calculus in order to figure all this out, in order to be able to discern what exactly, notationally I need. And I looked at this TensorCalc book, and I started kind of plowing through some of it because it was just like linear algebra. And I'm like, all right, this is going pretty well. And I hit chapter 3 and just brick wall. And I was so kind of like upset with myself, I guess, that like I'm not getting this. I don't understand why not. And I reached out to Pavel Grinfeld at Drexel up in Pennsylvania and said like, hey, I'm having some trouble with this, and showed him like, took a picture of where I was, and he was like, oh yeah, you don't want that, and sent me the link there to his updated errated book. And so I started working with that, and then I got to a point in chapter 3 where it was like, wait, so if I take a partial derivative on a nested function that has multiple variables at every level, it's basically parameterized on multiple variables. He was looking at this and said, oh, you're taking an ordinary derivative as one of these things. And like, that just did not make any sense to me, because you've got multiple layers of multivariate functions. So like, they're all going to be partial derivatives all the way down. At least I think, unless there's a t that's parameterizing all of it, and whatever. So I need to figure that out. But I looked at it again yesterday, 2 days ago, and something clicked. Like, I don't know what it was, but I was just like, oh. And so I pulled out my notebook. I pulled out the derivative that I was stuck on, and I was able to get the second derivative of this whole thing, which is really big and really ugly and really disgusting. And then it was like, find the second derivative on the other variable. And it's the exact same thing. It's just you're using the other variable. So it's the same thing. And then take the second derivative, one on each. Partial derivative on each of the variables. And so, okay, it's even bigger and even more disgusting, because you can't tease those things out. And then I got to, great, now use the tensor notation, or like prove that the tensor notation works. And I looked at it, and I looked at the tensor notation, and I looked at the stuff, and I went, wait, it's just you're going this way and you're going that way. Those are two different variables. We have two different dimensions that we're working with. So what do? Well, we have the dimension I over here as a superscript, and we have the dimension j over here as a superscript. And then I looked at it, and I'm like, what was so hard about that? It was not difficult. Like, I've been sitting on this thing for like 3 years, not making any progress whatsoever. Well, I do have while true learn. No, we got to get through this. So yeah, I learned the basic tensor notation from TensorCalc all by myself. So, woo! And come some number of weeks from now, I might be able to teach you all. Because it's not actually that hard. As long as you can do the ridiculous, disgusting, gigantic derivatives. Which I think the problem was, one, I started trying to shortcut them by bringing, oh, look, those two are the same thing, so bring them together, make it twice this other thing. And then also, I made a mistake somewhere on the product rule. Like, I just messed up a little bit on a product rule somewhere, and so I didn't do everything that I needed to, but I organized it I organized it correctly this time. So it was like I've got this nice little 3x3 that is representative of what happens when I take the partial derivative of f, the function. And then we've got this column of 3x1, which is representative of what happens when we take the other part of the product rule. Take the derivative of the other part, which is just one term each on each of the variables. So it turned out it was super easy, and it was just I just had some artificial roadblock in my head. Don't know what it was, but okay. So again, how do we effectively separate the keep thinking questions from all the rest of the stuff so that we know what we should answer? The answer is teachers figured it out in like 2 lessons. Right? You start looking at, are the students asking a question which is genuine? Right? Are they asking a question which is genuine? And to extend or to clarify the current question. Not to make you do the work or to just put themselves in a social role. Right? Only asking a question because they think it's the right thing to do. Right? So it's real easy to figure out with a little bit of experience which questions are going to be the keep thinking questions and the sorts of things that you yourself should also be asking other people when they get the right answer. Okay. And then again, how do we discourage those other types of questions, the stop thinking and the proximity questions, without disengaging those students, or while still getting those students to engage in the lesson, or to get them to start thinking about what's a better question for me to ask? Right, so here, first, those issues turned out to not be a problem at all, right? Teachers that I was working with quickly learned to discern between these question types. One of the things that helped this realization was that almost all questions asked in the first few minutes of a thinking task are either proximity or stop thinking, neither of which need to be answered. Just ignore them. What? Although the questions being asked early on in a task usually appear to be clarification questions, in truth they're often being asked in order to avoid having to do the hard work of discerning for themselves what is being asked and making decisions about things that are perceived to be ambiguous. So, right here, we've got the first few minutes tend to be clarification questions in the guise of, keep thinking questions in order to find the path of least resistance. And again, the sort of thing that you can think of if you're a teacher and realize, right, this is just a BS question. How can we get these students back on task? Right? How can we get them to start thinking harder about it for themselves? Once the task is up and running, it is equally easy to discern the nature of the questions being asked if you just keep in mind what the downstream effect of you answering the question will be. So, Downstream, is this going to make it easier for the student? Is it going to prevent them from thinking for themselves? Is this just for social points? Do you have no idea why they're asking this question? It's probably for social points, quite honestly. Are they asking for the activity more or less? Are they asking for more activity or less, more work or less, more thinking or less? But do keep in mind, in an environment in which you are only answering certain types of questions, students will get very inventive in how they formulate their questions in order to try to make it seem like they're trying to ask questions that you will answer. Often forming statements with an accompanying implied question lifting of their eyebrows. We're thinking this is correct. I.e., what do you think? Is this correct? Am I right? I think we're going the right way. Right? Don't be fooled by these pseudo statements. If their tone is inviting a response from you, really they're just asking a question. And by the nature of the disguise, it's almost always a stop thinking question. Focusing on the consequences of responding to their statement quickly helps you discern the intention behind it. Are they trying to get you to help them stop or keep thinking? If in doubt, just assume for the minute that they're trying to get you to help them stop thinking. I also made a note earlier where it said, in truth, students are often being asked to students are often asking questions to avoid having to do the hard work of discerning what is being asked and making decisions about things that are perceived to be ambiguous, to which I noted, ask about the source of that ambiguity, if there is in fact ambiguity or not, and then have them try both ways. That's often something that, if they're just BSing a question, that'll stop pretty quick because you're asking them to do twice the work. But if they're genuinely like, I don't understand this, I have this ambiguity, then if you say, try it both ways and see what happens, that's a little weird, right? Because now you're asking them to try multiple directions, which is, yes, it's twice as much work, give or take, right? From the point of split, from the point of where they split this question, it is twice as much work. But students who are genuinely curious about what's going to happen, this is a mystery. I don't know what's going to, oh, we need to work on this. This is going to be exciting for them because it's going to be like, well, if what do you think is going to happen, right? You can kind of like throw it out there. If you try both ways, see if you can figure out what's going on and what's the difference between these two things. And if you frame it as a mystery, it becomes much more interesting. Might start streaming studying sessions. Hell yeah, Famish, let's go. Can transition you to gaming. Yeah. Also that too. Several other people on the platform do stuff like that. And like you said, right, I think I tend to keep my sessions separate from each other as much as possible so that people know what to expect. But I've got 600 and... Oh, by the way, thank you for the follows and getting me to the goal. 660 followers. So, even if we only have 4 viewers, it's cool. 3 of whom are not me. But yeah, I tend to keep mine separate just because I want people to know what they're going to get. If I'm feeling particularly exhausted some night, I will just pick up a BS game. Balatro is one, for example, that, like, you can do Balatro any amount, anywhere, anytime. It doesn't really matter. Like, there's no real consequences. If you miss a stream of me doing Balatro, it's not going to matter. Like, oh, you got a couple new jokers. Like, that's it. Oh, you missed me going for, red stake on the gold deck. Oh, okay, well, we'll see what adventures you're up to tonight. So yeah, you may end up starting with doing transitions, so you have like two things that you're doing, a little bit of studying, a little bit of gaming. Like you said, if it helps with your ADHD at all, it's great. Help you focus a little bit, help ground you. And if you're going to stream Outer Wilds, let me know, because I'm going to be there. Let's see. And I don't think that I have ADHD, so at least I didn't used to. Society might have given me ADHD. It's fine. Okay, so as I said here, the first few minutes tend to be clarification questions so that the students try to find the path of least resistance. So, like, what's the least amount of work, what's the least amount of thinking that I have to do? Let's try and whittle this away and, like, oh, I don't really have to answer that part of this question or something like that. Obviously, they need to. They need to figure out what is important for themselves. And, like, why something might be important, or why they might think something is unimportant. As it turns out, thinking about this stuff is really some of the most important work that you can do. Okay.
There's more to Spotify than meets the ear. That's because video is taking center stage on Spotify, with over 300,000 video shows and 300 million users already watching their favorite podcast. With seamless switching between watching and listening, you can tune in anytime, anywhere. Got a show of your own? Upload your video to Spotify, turn views into fans, and monetize your passion.
Okay, so when coming at, or when in doubt, you don't know if something is a stop thinking or a keep thinking question, you could always assume that it's stop thinking and come at it a different way. So some of the responses, working with a team of 8 teachers, they came up with a top 10 list. It's far less amusing than, Letterman's top 10s, but nonetheless, oops, 8. I can count. I'm a math teacher. Nobody ever said that we were good at arithmetic. Number 1, isn't that interesting? Number 2, can you find anything else? Right? Something else that might be interesting, that's kind of hidden in all these other facts that are here. 3, can you show me how you did that? That is a great one, because now you are also getting to the bottom of how students think is more important than the answer itself. And occasionally they will admit, nah, I just got that off of somebody else. If they do that, don't slam them. Just be like, yeah, well, it happens, but that's not really the point of this activity. Right? Try to redirect it so that if anybody does, in fact, say that, oh, well, I just got this answer. Our group just copied it from somebody else. Our group totally cheated. Don't berate them and then be like, you're all getting Fs. No. Just remind them, correct them by saying that the answer really isn't that important. What's really important is being able to show me, being able to communicate your ideas. And even in that, I'm kind of stressing the word your ideas to try to get somebody to think I care about what you think. I don't care about what that other group thinks. I don't care if they got the right answer and yours is completely wrong. What I want is for you to tell me how you got this answer so that we can look at your thinking, the process that gets you there. That's what's important. 4. Is that always true? Right? You should know ahead of time if there are multiple answers or if there are multiple ways of getting to the answer, or if a student says that oh, well, this should work, and you know that whatever they're thinking will work great for positive numbers, but maybe it's not so cut and dry for negative numbers. You could say, is that always true? And oh, well, we've got an absolute value in here, so that might include more numbers than we, generally want it to, or it might do something different. I also came up with how can we verify that? Right. Some other little random examples of things that might not work entirely. What about the weight of a spherical object? In Calc 2, we had a non-uniform density. So how can we verify that your answer is correct on doing something like this? Well, we could come up with bounds. If we simplify it to uniform, right? You take the lightest density and then figure out what the weight of a spherical object with that uniform light density would be. And then you go to the heavymost density part of the entire sphere, and you say, if the whole thing were made out of that, right, and if it were uniform, then what would it weigh? Okay, great, we got bounds now. So then how could we work that in further? Well, we could do sort of like an average. So if we find a literal, just linear average of those two things, then, you know, it's not going to be accurate, but at least it'll get you a better guess than either of the two extremes. So like we want something that's probably around the middle of those two numbers, give or take. Which way is it going to go? Well, it kind of depends on the the function that defines the non-uniform density. If it spends a lot of time at the heavy end, and then spends a lot of individual spherical shells, essentially, at the dense end of the spectrum, then yeah, it's probably going to be more toward the heavy end. If it spends more of its I keep saying time. If it spends more of its radius looking at the light end of this non-uniform density, then it's probably going to be closer to the lighter end of those two values than the direct average. But again, you just get, like, start thinking about how this stuff should work in the real world. If it's a nice problem like this, all right, we can get all sorts of approximations and then try to reason through what this should be. And there are plenty of other like examples that we could come up with. I can't think of any at the moment just because I'm trying to get through trying to get through this before we hit the 2-hour mark entirely. All right, number 5. Good question. Why do you think this is? All right, so what Peter says on this page is what turned out to be more difficult than just discerning which ones are stop thinking, which ones are keep thinking questions, or proximity, are what to do if you have the proximity or stop thinking questions. How do you respond? So this was his top 10 list, like I said. I don't think I got quite all the context out. Are you sure? So you get that John Cena blurb. You sure about that? Does that make sense? And remembering what context you want to answer each one of these in, right, kind of matters also, because you don't want to like harp too much on, does that make sense? When somebody's like comes with a completely off the wall number, you don't want to insult them. So do be careful where you use each of these. How does your answer possibly make sense? Number 8. Why don't you try something else? right? So if something's not working, or you notice that a student isn't actually using the correct method, you might say, well, this seems to not be working for you terribly well, so maybe you guys can try something else. Now, there's other examples to do to help students notice things. And we will go over more of this in Chapter 8, where we foster student autonomy in the thinking classroom. But asking, have you looked around the room, is going to be right. Have you looked at the work of some of these other students who are around? Right now, this is going to come up in Chapter 8. We're going to talk about it more when we get there. But some students might feel kind of hesitant to go and check out other students' work because they might be like, well, it's just like lifting ideas from other people. And the answer is, no, not really. So what you're going to do is not go over there with the intention of taking their work and copying it and coming back to your group. Rather, what you're going to do is look at, real quick, look at the method by which they're working. So look at like just step 1, right? Step 2. What is it that they're doing? And do you know what that is? If the answer is yes, I know what they're doing, then it doesn't matter that you looked at it. You're going to still try it yourself. You're going to go back to your board and you're going to try it out yourself. And you might remember the exact process by which this works, but typically that's not the way your brain's going to work. You're not going to be throwing this on the board by rote memory. You're going to say, oh, what was it that they were doing? Right, it was this method. Let's write down that method. Let's write down the information we have, and now let's fit the information into this method. You're still doing the work. It's just that you needed a little push. Why don't you try another one? Even if a student group is wrong, if they seem to be like dead ending at the end of their work, and they've got the wrong answer, but it at least looks somewhat reasonable. If it's just like a clerical error, missing a negative, that sort of stuff, why don't you try another one? Is actually a really good one, because they'll be like, yeah, we got it right, and they'll go away, they'll do the next one, and then eventually, at some point, they may realize that something's not right. Something's wrong here. This didn't come out the same way as that one. One particular method that I like to use in my pre-calc classes, and even Calc 1, was, have you graphed it? Right, because if they know what they're looking for, then coming up with a graph for this, and then them being like, oh, the graph doesn't match what I wanted the answer to be. It doesn't get us positive numbers in this region. It doesn't do whatever, That becomes really powerful too. So again, coming up with the tools to try to figure out how all of this is going to work is a really great way to operate. And anybody actually using this, you're going to come up with your own questions. You're going to come up with your own ideas in the moment, and that's exactly what you want to do. Use some of these as like starter questions to get you thinking about what to ask them. But once you start seeing what situation they're in, you can tailor these to being like, I kind of want to ask like this one, but sort of that one. You know, just start tailoring it for their particular situation. Again, have you tried graphing this? Number 10. Are you asking me or telling me? Each of these suggested responses is a variation of answering a question with another question. I said that earlier. Some of the teachers I was working with became quite proficient in using this list, and for them, these responses were effective at redirecting proximity and stop-thinking questions. But these teachers were among the minority. For the majority of teachers, answering a question with a question became a slippery slope into revealing more information than they initially intended. So consider the following interaction. Why didn't you try something else? Oh, like what? Maybe you need to consider the cases where x is negative. Oh, you mean like this? Yeah, sure. Oops, we're just back in the same place that we were before. What we found that answering a question with a question, and only a question, one single question, was only effective when it was immediately followed by the teacher walking away. Just walk away. No other statements or suggestions being made at all. In fact, this was so clear that we decided to try this strategy by itself. We would just walk away. This turned out to be infuriating to students and did cause some negative backlash. But after 2 weeks, we also noticed it caused a sharp decrease in the number of proximity or stop-thinking questions being asked by students, in some cases reducing the number to fewer than 30 questions a day. Students began to realize that their questions weren't going to be answered, so they stopped asking them. Except in the primary grades. If a 6-year-old asks a question and it is not answered, what happens? Zach, with the number of children you have, right? If you ask a 6-year-old, or if a 6-year-old asks you a question and you don't answer it, what do? Sorry to call you out. I think probably most people in chat can answer that question as well, even if they don't have children. Right? If a 6-year-old asks a question and it is not answered, they will ask it again. And if it is still not answered, they will ask it again. And if it is still not answered, they will do something, quote, that a 16-year-old does not do. They reach out and they touch the teacher. Right? Tap them on the arm, pull on their clothing, and if the teacher walks away, they follow them. I have multiple videos of kindergarten and grade 1 teachers walking around the room with a row of little ducklings follow them. As soon as the teacher stops walking, they are immediately surrounded by little ducklings tapping on their shoulder and tugging at their clothing, asking them the same question that they didn't get answered over there. These episodes of primary teachers trying not to answer students' questions by just walking away prompted us to explore some nuances of this strategy at all grades. For students, there's a big difference between having their question heard but not answered, and having their question not heard. No one likes to be ignored, so we made a modification to the walking away strategy. Instead of walking away when a proximity or stop thinking question is asked, we would instead look at the student and smile as they ask their question, then we would walk away. This turned out to have a huge effect on the perceptions of students at all grades. Instead of feeling ignored, they now knew that they had been heard and that the teacher's decision to not answer them was deliberate. Many students took this to mean that they needed to do more work. Over time, students began to see the smile and walk away as a sign that the teacher had confidence in their ability to resolve the question on their own. There were still a few students who were frustrated by these encounters, but they were thinking more or no longer having the teacher do their thinking for them. When coupled with the aforementioned building thinking classrooms practices, students perceive the smile and walk away as you have confidence in their group and the room as a whole to resolve their question. This is not to say that students shift their questions from the teacher to their group mates. Students don't ask proximity questions of their peers. There's no need to establish their role as a student within their peer group. They do still ask their group mates if this is right, however, because their group mates do not have the same authority as the teacher. These questions are asked and answered with a level of tentativeness, yeah, I think right, I think it's good, that then keeps the students going. So they're still more interested in than resolving whether or not they're actually right. All right. So, the clearest thing that can be done for these students that are asking the stop thinking and proximity questions is answer with a sly smile and walk away. They see this as you having confidence in their abilities. And ability to resolve the question on their own. All right, ads are about to start. We will then work on the FAQ, the other little things that are in the end of this chapter, and then head out on a raid. So thanks so much, everybody, for coming. We got 3-minute ad, and then we'll wrap up.
Play the music the moment is calling for. Whether it's turning up the party,
Alrighty, so
save the day's soundtrack with ad-free music listening and offline downloads in Spotify Premium. Tap the banner to learn more.
nope, not that one. That one. We're gonna do some eskrima, and then we're gonna do probably also karate. Gotta keep the skills up because otherwise I'm just not gonna be doing Tangsudo karate for another 2 years, give or take. So I'd like to make sure that I at least don't forget stuff like I did last time I had a 3-year break, which was for COVID. Yeah, go figure. We weren't going to do in-person activities for a while. We okay? Yeah, we're good here. So I learned Eskrima, at least the first, year or so that we've done it, here in Yorkshire with a guy who teaches. There are 5 students, I think, in total out of his backyard. So he teaches us in his private dojo, which is the in-law apartment behind his house. It has a nice big open space in the main room, which has like big, gigantic sliding glass doors, which is great, but it is kind of noisy for his neighbors, especially with all the sticks clacking together as late as 8:30 at night, which, like, whatever, but some people don't like that, I guess. But he's been trying to get his own space, and that's pretty cool. So we'll see if in the fall we get our own space now, and can actually work together with him to build the practice and build his dojo. All right, so Eskrima mostly is being done pretty much almost square on, or just taking a step back like this. There isn't a whole lot of footwork in the style that he has particularly done. However, I would suggest that probably people need to work on footwork. It's just a matter of practicing what feels natural and then going with it. So typically I am right foot forward if I'm going to go right hand forward as well. And again, we're sitting about here. We want our hands somewhere in front of our sternum to prevent anybody from stabbing us. This is where it's from, even if it's not technically realistic. And we want to keep the butt of the stick, or in a real case, machete, pointing at your opponent so that they cannot see what the tip of the machete is doing. So here we typically get our standard hits are going to be, we come out with the stick, it goes about eye level, so you're slashing across their eyes if potentially possible, and don't go that far. And then we use our backhand as a counterweight. This also keeps the form in the muscles in your back, so that you're doing this with both sides, and then doing this with both sides. So you're going out and then in. And if you work on those machines at the gym that do this, right, the ones that start at about your shoulders and then curl to the front, those are pretty good at working your back muscles in the appropriate location. So typically these are just strike out, bring back, strike out, bring back. The second, right, those are called number 1. Number 2 are, we do 2 of them. That's it. Number 3, and most of these start with a single hit and they end with a single hit. So what we're doing with the number 3 is coming out, bringing it back over the top. Nope, that's not right. Out, back, over the top, strike, and bring it back over the top, and then single strike again. So this is going to be 1 over 1. And again, typically try to hide where this is going in your wrist. The fact that this is going to be kind of up and over, right? When it's traveling here, it's going to be pretty easy to see that it's moving. What direction it's moving is not always easy to see. So, I mean, somebody who's experienced in like fighting generally, not specifically in Eskrima, will still know like, oh, this is going to come out again, but when you start going like this, obviously it's coming up over the top. So they'll be able to figure out what's going on. But if you train this fast, you bring it back over the top and strike out, and now we might be able to do something different. All right, number 4 is a single strike out and then move to open stance. A single strike from open stance, where we end up using our forearm or our hand to stop our forearm and allow this thing to whip. And then also, when it whips, we want to change direction and bring it back over the top and go back to closed. And then single strike. So, single, drop, single, drop to open, strike, direct, redirect, and single again. Single, drop, redirect, single. Let's see. Number 5 was a single back. See, this is a 3. Yeah, I think it's a single and then drop to open. And I think from here... now I can't remember. It's been too long. It's like a straight down strike. And then bring back... yeah. I'm going to have to look that one up again. We get a number 6, which ends up doing a lot of similar kind of stuff. From closed position, we also have what's called a fan block. So we take this and we do a backhand block over our heads, and then a forehand block, and then what's called a kadlik, where we whip this around using our body weight. Usually we come back up and then sink the body weight and twist, which causes the entire system to end up whipping around, puts most of the energy in the hand, and then single. So we end up doing the fan block kadlik strike, and a bunch of other stuff that we can do with other way. All right, with 2, then we can do a number of combinations. So we've done this multiple times on streams. Pretty much any time that I do good form, I'll do Sticks to Heaven. So this ends up being a 45-degree angle strike, followed by a redirect to the other shoulder, 45-degree up angle strike, a twist and a swap, which is also a 45-degree angle strike, and then this returns to the hip, and now we're on the other side. So we do the same thing going this way. Now we're back to our original position. There is also the alternative, wherein instead of coming up at a 45, we can also block in at a 45, and then swap in. That one's called Sticks to Earth, I think, or Heaven to Earth. So you're basically doing like something that's grounded and something that's... They use some 4 elements type stuff. That's a little interesting. I'm not exactly sure what it is. We'll get there. And then we also have a number of other things. So one is that we can use the part of the fan block and the kadlik from this position. Unfortunately, we're not able to really do a backhand anything usefully Because A, it's at our head level at the moment, and B, if we try to come off the shoulder, like, this is telegraphing immensely what I'm going to be doing. So this can only really be used as a cheeky sort of thing if you come up over the top with a forehand strike. And then we can do a kadlik from here. Usually this is done in coupling it with something else. So oftentimes we do like a... let's see. What's the other way to get there from here? Is that it? No, not really. I want to say there's like a strike up and then return that way so that we can go back to the other side, but now I can't remember. Anyway. I think we can also just do that from here, but the problem is that I end up crosshand. That's not particularly a good idea. Although if we do end up here, the other way to get out of this is simply up strike with both. So 45-degree strike up to the shoulder. And these are particularly nasty. Again, keep in mind this is supposed to be a machete. 2, in fact. Then we also have triple strikes, which typically are going to be like come across with a 45-degree angle strike. Then, again, I'm cross-handed. Huh. Am I supposed to be doing something else? I think I'm supposed to be doing something else. Oh, that's what it was. Yes. Okay. So it's a 45-degree angle strike, but then immediately come up and over the top. The left hand then comes across the middle and then goes to the shoulder. And then the third is a 45-degree angle strike, which comes back down like that. So we end up with something like that. Which then puts us in a pretty good position to do anything else. Now we're just on the left. Same sticks to heaven routine. We can do that. Let's see. There's also the... There's others. And now I'm just forgetting exactly what to do. From here we can always go to figure eights like this. We can go forward. We want both hands to have their turn on top. We can go backward. We can then go singles, forward, backward, forward, backward. Right. And, oh, follow. And then we could do the follow along, which is going to be a lemniscate type shape. Again, figure eight. But instead of just one, you're going to do two. And basically, instead of being opposite each other or exactly in the same place, one is following the other at about like 1/8 of a cycle behind. So this is your sine and cosine. Hang on. There we go. Change grip. So this is your sine and cosine function, right? One is going and the other is following behind it just a little bit. All right, so that's eskrima. Filipino sword martial art, which our instructor also uses. We'll let karate go today. We got to get back to this stuff. We have also done Chinese broadsword and noted the similarities and differences that exist in Chinese broadsword as with eskrima, and it's very interesting to see what's going on. So we're gonna randomize. It's not really that random. S. Okay. Now we are reading vocabulary words from John Gould's Maine Lingo, a wicked good guide to Yankee vernacular. This is introducing everybody to the world of Down East Maine. It is a particular accent, a particular storytelling style, and it usually is in the neighborhood of Bar Harbor, or as they would have it, Bahaba. And so, like I said, we usually do like a little bit of my HOTAS here is very unhappy. What is going on? Did the connection come undone slightly? I get the feeling this happens a lot with X52s, which is too bad. I really hope I don't have to open it up and solder because all right. So in Down East Maine, let's go with the okay. Slumgullion. 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 In whaling and sometimes other fishing, slumgullion is the oil, blood, salt water, and general crud that occurs in the flensing. Mainers and Massachusettses like to call that flenchin or flinchin, known too as lipperins or dreenins. Slumgullion is a considerable more than gurry. Slumgullion is now used for anything that is too southern. Slumgullion is now used for anything that is an unpleasant mess, and particularly poor food. Slumgullion. Let's see. And slicer. Maine shipwright's term for a long-handled and wide-bladed chisel. Slicing is thus chiseling, and Mainers use slicing for chiseling, both in the sense of haggling a price down and in that of working or worming your way in. He sliced him down to $4, and she sliced herself into a club, i.e. chiseled the price and chiseled a membership. Slicer. Okay. Let's bring her home. So, as we talked about before break, just up there, the basic idea is that through the Building Thinking Classrooms framework, what we want to do is to just answer with a sly smile, knowing smile, and walk away. This may very well infuriate some students, but again, the majority of them will see this as you having confidence in their abilities and the ability to resolve the question individually or as a group on their own. So they will no longer see this as like an affront to their sensibilities, but anytime you hear a question that is just like, you know, this is too much work, can you do this thinking for me? Just, again, walk away. That's it. Smile and nod, walk on. Again, students will see it that you have confidence in their ability to resolve that question on their own, and that you are not going to encourage that particular kind of question or that particular kind of thinking to just sit out there, right? They're going to have to do a little bit more work in order to get you to acknowledge them. Question: what do we do when a student or group of students insists that I answer a stop thinking question? This happens most often in the context of an "is this right?" question. The easiest way to deal with this is to call it like it is. I'm not going to answer that question. And tell them why. Me telling you that the answer is right is worth basically nothing. If you can tell me that it is right, however, that is worth everything. Then tell them that you have confidence in them, and I believe you'll be able to tell me if this is the right answer on your own. Keep going. In some instances, you may wish to couple this with a hint. See Chapter 9, which, again, we'll do in a few weeks. How do I tell the difference between a keep thinking question that is asked as I am moving around the room and a proximity question? The key difference between these question types has to do with the activity of the student or group of students at the time the question is asked. If the students are busy working away at whatever task is at hand, any questions they tend to ask are going to be proximity questions. Oh, for number 3, are we supposed to find all the answers, or are we doing this right? That sort of thing. Keep thinking questions, on the other hand, tend to come when students are at an impasse and need something from you in order to move forward. In these cases, in some cases, these were a request for a hint, which again, see you later. We're having trouble here. Were we supposed to do this for all possible sizes or an extension? Are we supposed to now look at the general case? Why, yes, in fact, go for it. Should I tell my class about the 3 types of questions they ask and that I am no longer going to be asking proximity and stop thinking questions? As it turns out, this is the first practice where we experimented with talking to the students about what we were doing. When done correctly, 2 interesting things happen. First is that the students started to self-regulate the types of questions they were asking, and in this regard we saw a huge decline in the number of proximity and stop thinking questions, coupled with a small uptick in the number of keep thinking questions being asked. The second thing that happened was that the students started using the language of the 3 types of questions in order to moderate their own peers. Dude, she's not going to answer that. That's a stop thinking question. The challenge here was doing it correctly. In this regard, we learned that talking to students about the practice before initiating it almost always resulted in challenges when the implementation began. From interviews with students, we learned that students perceive pre-talks to mean that the teacher is asking them to behave themselves during this implementation. By extension, this meant that the teacher was asking their permission to make this change, and in the minds of some students, this gives them the power to decide whether or not this is something they want to do or not. On the other hand, talking to students about the practice after 2 weeks of not answering proximity and stop thinking questions, coupled with a lot of smiling and walking away, was met with very positive reactions. Ah, so that's what's been going on in this classroom. This was not perceived as asking permission, but rather an explanation for something that had already started and become an implicit part of their classroom norms. Students also appreciated the peek behind the curtain of teaching. Hey, it's really cool that he told us that. I like he's really thinking about what he's doing as a teacher. This distinction between pre- and post-implementation discussion played out the same every single time we experimented on talking to the students about why we were doing it and when we had done it, irrespective of the practice we were talking about. Though many of the same things were said in both instances, the students perceived pre-implementation conversation as us asking permission, and post-implementation practice as inviting them to understand the reasons. I can see how smiling and walking away, though infuriating for students at first, can become a good way to avoid accidentally answering a proximity or stop thinking question, and thereby a good way to get students to keep thinking. But does it work for everybody? Well, yes and no, of course. There's more nuance in every answer. There's more nuance in every classroom. It works in that you're not letting them stop thinking. It doesn't work for all students in the sense that there are some students who cannot get past the fact that you have not answered their question. This may be because they're insecure about their own abilities. They have learned helplessness, or have some sort of behavioral disorder or what have you that does not allow them to move forward unless their question is resolved. But you know who those people are. And you know precisely what needs to happen for them particularly. I did have one student who had an autism spectrum disorder, and it was very hard for her to understand why I was doing certain things, but the second I let her know that this is why we're doing it, she was like, okay. I can deal with that. This was also a small class of 5 people, so I think it started around like 10, but only 7 or so went regularly, and by the end of the semester it was down to 5, and that was it. It was a little sad. Alternatively, you may have students who become incensed at your deliberate disregard for their question. After all, they have a lifetime of experiences, especially at community college, with teachers answering their questions. Or it may be some combination of all these factors. Regardless, you may need to read the situation and know when a nod, a wink, or an encouraging remark, I have complete confidence that you can figure this out, is needed. Keep in mind, however, that when you open your mouth, you may be overcome with an almost undeniable desire to answer their actual question, and such is the nature of teachers. Although we had great success with smiling and walking away in K through 2 classrooms, there were some settings where several students did not know how to process the signals that these actions were meant to send. In these instances, teachers would smile, say a few encouraging words, and then walk away. Over time, they could stop with the encouraging words and just smile and walk away. What is important, however, is that you do not answer proximity or stop thinking questions. Just leave that there. And that you read the situation so as to be able to give the best response at any given time when such questions are asked. How do parents react to the teacher not answering questions? Well, this depends on who tells them. If you leave it to the students to tell their parents that you are not answering their questions, I think you can imagine what their reaction is going to be. Students, at the best of times, are not great at communicating the nuances of what happens in their classrooms. Couple this with a parent filtering what they hear from their child through their own experiences as a student, and you likely get an email or a phone call. If, however, parents hear from you that you are doing everything to encourage your student to think, and that you will be supporting that thinking through how you selectively answer and don't answer student questions, the response tends to be much more amicable. So, in other words, trust your parents. Maybe give them some of the information on Parents' Night, if you have one. Right? Let them know what precisely is going on in the classroom, and that we are doing this thing, and that it would be really great if you didn't tell their student some of the behind-the-scenes stuff. You will reveal it to them as time goes on. I've been implementing thinking classrooms for a while, and there's no way that I'm getting 200 to 400 questions a day. What kinds of classrooms were these numbers coming from? The 200 to 400 questions a day data comes from classrooms where none of the thinking classroom practices were being implemented. As you begin to implement these practices, the numbers dramatically decrease and in some cases get close to zero. Zero questions asked of the teacher in a single period. So, smiling and walking away is a strategy after the question has been asked. Are there any strategies that can be used before the question is asked to prevent that kind of question from being asked at all? There are 3 strategies that we played with, first of which involves strategically reducing proximity. The first 3 to 4 minutes after a task is given is by far the period of time in which the greatest number of questions is asked. And during these 3 to 4 minutes, stay in the very center of the room as far away from all students as possible. And by distancing yourself from those students, you reduce proximity questions. Doesn't always work in every classroom. Decide for yourself how that's going to work. One of the possible ways for me to do it was there was a group of 6 desks that were in the direct center of one of my classrooms. I could just sit on that. Or on my more ridiculous days, stand in the exact center and just like keep spinning around and looking at everybody and what they're working on and everything like that over the first 6 minutes or over the first 5 minutes or so that the task was given. I would just be standing on the desks and like they'd look over at me and just kind of giggle to themselves or be like, what the hell is this guy doing? But eventually, right, like, nobody wanted to come over to me to ask a question. They would occasionally ask a question from their particular position in the room, wherever that was. And some of them, there was no discouraging them, but nonetheless. The second method is not to provide any answers to any questions asked by an individual student. Individual students ask their group members, and then the groups ask the teachers. So if a student approaches you with a question, respond with, what did your group members give? Or did you ask your group? If the answer is that the group doesn't know, then follow the student back to the group to hear exactly what the question is and talk with each of the members. This is not to say that you will answer their question. You might just give a hint, or you might just smile and walk away. The third method is to lead with your own questions when approaching the group. So what are you doing here? And like point at something or circle something or what have you. Can somebody explain what's going on? What do you know so far? By leading with the question and developing further leading questions, which are again furthering student thinking, not stopping student thinking. You are then controlling the conversation, and it means that if you give encouragement or hint with a smile, you are not doing so in reaction to one of their questions. So lead with a question so that you are controlling the conversation and you're not pointing to one of their questions as being a good one. All right, so macro move. Answer only keep thinking questions. Nothing else. At all. Right, micro moves. When asked those questions, which are proximity or stop thinking questions, redirect. Ask your own questions. Or just smile and walk away. Right? You've heard them, you understand, but at the same time, I think you got this. And after implementation, about 2 weeks. Talk to students about the practice and the why the types of questions actually do matter. So give it 2 weeks. Just do all of this stuff along with everything else that you're doing. Don't tell them why you're doing it pretty much any time during all of it. Because again, if you're doing it before or during the first 2 weeks, you are asking their permission which they may withhold. Two H's? Damn it. Two H's. All right. Yeah, because otherwise it's withhold. All right, questions to think about. What are some of the things in this chapter that immediately feel correct? Again, right? It's always the same question with Peter for the first one. So what feels right? Well, I mean, the different types of questions that are asking, I get them all the time in classes. And yes, it makes sense that while reading this, we're thinking, okay, a lot of the students want to minimize the effort that it takes to worry about mathematics, especially, because this is not their subject. They're doing this for a gen ed requirement. They don't care. Even the ones who are doing this for a major, right? They're probably computer science. Probably not physics. Unless you have a specific class that is like all STEM people, right? Most of them don't care. They're not going to think of mathematics as like a super important thing apart from what can get them from point A to point B. What's going to get them their degree, right? None of their classes really matter all that much, except maybe the ones that are specifically aligned to what they want to do. Which can be slightly saddening. If you have any of these students who are just like, this is not interesting to me. I'm just doing this for the class. I'm just doing it for credit. I don't care. But by showing them that there is a higher way of thinking, there is a higher way of being in college, at my level, right? Or for any high school students, any middle school students, you can show them that, you know, this this type of metacognition of thinking about the kinds of questions they're asking and why they're asking those questions is actually a super important part of what's going on. The introduction talked about institutional norms being a potential source of student disengagement and lack of thinking in the classroom. This chapter talks about the way we, as teachers, answer questions as contributing to students not thinking. In what other ways do our interactions with students reduce or remove their need to think? I should have prepared more answers for this, I think. And I think in the future I will attempt to do so. But I think essentially, right, what are we working with here? I think there are a number of practices which show students how much we care or don't care about certain things. So there's a whole section in here about homework, and if we're just like, hey, do these exercises from this book, do the students think that those are hand-picked to, like, get them to think about things or understand things, or do they just see them as hurdles to get over that are in the way of them doing the really important work, which is whatever their major is or what have you? I typically turned office hours into a lot of, like, philosophical discussions. Shocking, I know. So eventually they would get their questions answered or what have you, but it would eventually become more of like, so why do we ask these particular kinds of questions? What is it that we're really after? What is it that we really want? You know, some students, again, did not care. They were just there to get the check mark on their transcript that said that yes, they completed their math requirement or they completed their gen ed requirement. Fine. But I reached most of even those students with some actual discussions, and they were able to come in and discuss with me exactly what it was that they were after. And what was it that I was after? Why is it that I care so much about, you know, every individual student understanding the, you know, volume of a sphere and how that all works? I don't care about the volume of a sphere. I care about whether or not you can think through something. I don't care if you know the formula. You can look up the formula. Who cares? But the things you can't look up are the more important things. That's not what I wanted. That is not what I wanted at all. There you go. Many of the practices for building thinking classrooms discussed to this point are ways in which we can create environments that get students to think. The practice discussed in this chapter, in many ways, is the opposite of this. In this chapter, you learned about ways to avoid doing things that stop thinking. What are some other practices that stop thinking? I think I already kind of talked about this a little bit in our, you know, in what other ways do our interactions with students reduce or remove their need to think? I might have also kind of run into this one as well. Right? So your choice of homework is going to get students to avoid thinking as much as possible. Even just the need to do homework sometimes is going to get them into this rote mode where they're just doing something in order to do something rather than doing something in order to think. So I think we need to be more careful about what particular problems we're assigning. And again, there is a chapter in here on homework, so we'll get there. But essentially, the homework that's there is voluntary, and it's basically just for your information. These are the problems that you need to work on in order to figure out things. If you already know how to do something, like come to me with questions, or come to me with a demonstration that you understand something, and then we will have a discussion about your understanding. And then and only then do you get, like, actual grades out of this. But we'll discuss it as we get there. What are some challenges you anticipate you will experience in implementing the strategies contained in this chapter, and what are some ways to overcome them? So I was kind of a little bit worried about the duckling thing, because although they are college students, a lot of them are very codependent upon their teachers, and they're just like, oh my goodness, I need reassurance every single second of every single day. Some of you might be like this as well. No offense. Sorry. It is important to try to get students to be a little bit more independent, and that comes in Chapter 8 when we're talking about more classroom autonomy for individual students. We'll get into some of the other stuff as well as we go on. But for now, challenges that I had specifically, I don't think I really had that many challenges in adopting this, like, smile and nod and walk away thing, because a lot of times I kind of that's kind of like my normal operational mode, I suppose. I did actually have a lot more because of my choice of Socratic style. I did have a lot of times where I was like, I can't do that. Like, I can't answer this. I need to move on. One of the other issues is that you have to keep moving in this classroom. You can't just sit there and talk with 1 or 2 or 4 students. You need to move between groups, and you need to keep circulating, because you don't have the time to, like, harp on a particular thing and try to get their individual perspective in this exact moment. You need to talk with the group. You need to get them to discuss what they know and what they don't know, and then you need to get that marker in somebody else's hand most of the time. All right, so try this. These are the following thinking tasks have been shown to generate a lot of student questions. Therefore, using these is a great way to practice not answering proximity type questions. So, K through 4, ice cream cones. The Ice Dream ice cream shop has 10 flavors of ice cream. How many different 2-scoop ice cream combinations can you make? What about 11 flavors? What about 12 flavors? What if there are 20 flavors? What if each cone had at most 3 scoops? So getting students to think is going to be the biggest part of the thinking tasks at the beginning of the class. And again, if they keep asking you proximity or stop thinking questions about these, then they're definitely going to be asking them during the regular lesson. So what you want to do is then ask interesting questions that are, like, within reach, just tantalizingly close to what they already know, but it's like just a little bit of an extension so that they can look at this and be like, you know what, we don't need to ask the teacher. We've got this amongst the three of us. We can figure it out. And then if they do have a genuine question, they can come up and ask. Grades 5 through 8. Palindrome. A palindrome is something that is the same forwards as backwards, like mom, dad, race car, I prefer pie, was it a rat I saw? Numbers can also be palindromes, like 141, 88, 1221, etc. Now consider the number 75. Okay, 75 is not itself a palindrome, but let's reverse it and add it to itself. So 75 plus 57 is 132. Okay, 132 is also not a palindrome. Reverse it, add it to that number. 132 plus 231 is equal to 363. 363 is a palindrome. We call this a 75 is what is called a depth 2 palindrome. So it takes 2 steps of doing this process of reverse the number and add it in order to get a palindrome. Find the palindromic depth of all 2-digit numbers. Grades 9 through 12. Wine chest. Mr. Snooty loves red wine, so much so that he drinks 1 bottle of wine every day. Do not do this, it's not good for your liver. But he is very particular about his wine. First, it has to be the right type, and second, it has to be the right temperature. And third, it cannot have been exposed to light more than 5 times. To make sure that it is the right type of wine, Mr. Snooty goes to his favorite wine store, which is very far from his home. To make sure that the wine is at the right temperature and not exposed to light, he has built 2 temperature-controlled wine chests in his home, one much bigger than the other. How often does Mr. Snooty have to go to his favorite wine store? Mr. Patootie shops at the same store as Mr. Snooty, likes his wine at a certain temperature, but will not drink it if it has been exposed to light more than 10 times. How often does Mr. Patootie have to go to his favorite wine store? Okay. So those are going to be the interesting problems that we're working on. We're going to attempt in the next 2 weeks to look at questions from Chapter 6 and try to divine some better answers than me thinking about it in the moment. Although it does kind of feature the genuineness. Okay, so we are leaving for New England to go to a wedding on Wednesday morning, which means that Wednesday night I will not be streaming. So tomorrow, Tuesday, we will be streaming 9 Souls again for our second stream, and we will be leaving on Wednesday morning and not coming back until the following Thursday. So maybe that Thursday I might feel like streaming, but chances are I'm going to be pretty jet lagged and not feel like it whatsoever. On the other hand, if I'm not feeling too bad, I may very well be jet lagged in the other direction, which means that it's going to feel like 7 p.m. Actually, it's going to feel like 4 p.m. during my normal start time. In which case, I might just go like practically all night. We'll see how it goes. And then next Friday, the 30th, is likely my next stream after the 20th. So we'll see how things go. We're going to go over and raid Paleontologizing. This is Dr. Danny Anduza, who is a paleontologist. And currently he is talking about fossil science and doing a Q&A session. So if anybody is interested in watching this, he's really engaging. He's really awesome. I absolutely love Danny's work, and he has been back from an actual fossil dig for, I think, a week or two, something like that. So we'll see you all later, hopefully tomorrow, and then after that, not until the 30th. So good luck, everybody. We'll see you later. My name's Obi-Wan Pez. This is N Simplex Pachinko. Bye.